Hello everybody, welcome back to Math 245. Today is our last day of learning new material. Congratulations, you have made it to the end of this very strange term. Good job, everybody. I know that this term has been pretty wild, so good job. Today we have two lessons, lessons 58 and 59. This first lesson is about something called the margin of error. Sometimes when we take a survey, for example, we find something like 40% of people agree with a certain statement. But we can't actually be true that 40% of everybody agrees with that statement. And so we have to come up with this margin of error, and that means how certain can we be that 40% of all people agree with a statement when we take a survey of a small number of people. So a confidence interval tells us the probability that a parameter, such as the mean of a set of data, will fall in a certain interval. The margin of error is half the width of the confidence interval, given by this equation, where n is the number of people in our sample. So when we take a survey, right, we cannot take a survey of everybody. So this margin of error tells us how certain can we be that this statement is true for whatever percentage we found to be. So let's do a couple examples, and then we will see what they mean in context. So a survey is sent out to 200 individuals to see if they support building a new city park. If 95 responded yes, what is the margin of error? So we are sampling 200 people. That is the number of people in our sample. So that will be our n value. So I see that E sub m is equal to plus or minus 1 divided by the square root of 200 times 100. This is also known as 100 divided by the square root of 200. What is the square root of 200? The square root of 200 is 14.14. And 100 divided by 14.14 is 7.07%. This tells me that the margin of error is 7.07%. What does this mean? Well, 95 people responded yes. So what percentage responded with yes? Well, we have 95 out of 200 responded yes. So this is 47.5%. So from this survey, 47.5% are in support of building a new city park. But there are obviously more than 200 people in this town. So this 7.07% tells me how far away my actual percentage could be from 47.5%. So if I take 47.5 minus 7.07, this is my lower bound. So 47.5 minus 7.07 is 40.43. And 47.5 plus 7.07 is equal to 55.2. Whoops, 55. Nope, that's not right. Sorry, 47.5 plus 7.07 is 54.57. So we know, we are pretty sure that between 48.43 and 54.57% of people in this town support the park. So let's write that down. We are confident that between 40.43% and 54.57% of people support the park. So really this margin of error is just giving us a cushion maybe on either side of whatever we find a percentage to be because we cannot get everybody in a sample. It's worth noting that the more people you sample, the bigger that n is, the smaller this margin of error will be. So instead, if I surveyed 400 people, my margin of error would be a little bit smaller because we are surveying more people, so our confidence interval would be a little bit thinner. This right here, it would be a smaller interval. All right, let's do one more example. A local pet store conducts a survey to see how many households own pets. The survey is sent out to 400 households and 120 respond that they have a pet. What is the percentage range of houses that own pets? So from this survey, we might just say, oh, okay, well, 120 out of 400 people have pets, so we just take that percentage and call it done. But because we only surveyed 400 people, we cannot be totally sure that that is the actual percentage of people that own pets. So we need to find our margin of error. I see that E sub m, here are the number of people we're surveying is 400. So this is 1 divided by the square root of 400 times 100. This is equal to, 100 divided by the square root of 400. The square root of 400 is 20. So I have 100 divided by 20, which is 5%, plus or minus. So whatever percentage we actually end up getting, we can be very certain that the actual percentage of people who own pets is within 5% of that number. So what percentage do we get here? Well, I see that 120 divided by 400 people actually have pets. So 120 divided by 400 is equal to 0.3 or 30%. So from this survey, it appears that 30% of people own pets, but we only surveyed 400 people, right? So if I take 30 minus 5, I get 25%. That's our lower end. And if I take 30 plus 5, I get 35%. So we are confident that between 25 and 35% of people own pets. We can see here also, here our margin of error was 5%, which is smaller than what we found in the first example, which was 7.07. And this is smaller because we asked more people. We asked 400 instead of 200. So the more people we ask, the smaller the margin of error will be. All right, that is it for this lesson. We have one more lesson, so hop on over to lesson 59.